Hello everyone, I hope you are doing well. Today we are going to be looking at object-oriented programming. So before, we've mainly seen modular programming, where we kind of divide our program into functions, kind of group these functions together, and then call on these functions. Object-oriented revolves around classes. So you're going to create your own object which you can interact with. We're gonna see some examples here. So today, let's kind of just jump into the code to talk about some examples. Kind of going off what Jen was talking about last class, let's say we had a car. Well, a car has a lot of attributes to it that differentiates it between other cars. So we know the make, the model, the year, amount of tires, color, stuff like that. You can have a car and then all this different information kind of differentiates it between other cars. And so what object-oriented programming allows us to do is turn car into its own object, such that it has all this information in it. And this will allow us to create an instance of car, which just means we're going to create an object of car that has these different parameters. So we could declare a sports car, and it will be a Porsche GT3 and 2020 with 4 tires, and we're going to make it lime green. So we can go ahead and do that, and then we can interact with this particular instance in different ways, and we're gonna call these setters and getter methods. I think the best way to go about this is just kind of show you an example of object-oriented programming. We'll build out this car object. We'll instantiate some objects, and we'll just play around with it for a bit for this lesson. So we said that object-oriented programming revolves around classes. So how we're going to do this is we're going to create something called a class of car. We can name this anything we want, but we're just letting Python know we are creating a class here. And so all functions and attributes that are connected to car are going to go inside this class. When you instantiate an object in Python, there is a function that always runs, whether you've defined it or not. And it's called a constructor. And so we can actually kind of set up our object when we start it for the first time. So every time we have a new car, Python's going to create an instance of class car, and it's going to run something called the init function. And this is something we can write ourselves. If you don't write it, it's there, but there's nothing in it. But we can actually define it. So we can define init. And we always want to pass it self. And what self means is, hey, I'm a particular instance of car, and I'm referring to myself. I'm not referring to the class as a whole. I'm just referring to this instance. So if we had one car, which is a Porsche, and we had another car, which is an Audi, and we're in the Porsche instance, we want to make sure we're talking about that specific instance. And you'll see that come up later, but for the init function, we just kind of want to give it itself as a parameter here. And so we can just do something simple here. Hello. So every time we create a new class of car, it's just going to print hello. That'll let us know, hey, the class is working, the instance is working, it started up, and it said hello. So we can go ahead and define a new car, car1 equals car, and we can kind of run that and see what happens. Python oop.py, hello. So we created a class, we created the constructor, otherwise known as init, we passed itself, and we just kind of had it print something to let us know that it's working. So even though we didn't call any function, we kind of just created or instantiated a instance of that object. It went through and it performed whatever was in init. And so we can actually do some more stuff with init. We can pass it a lot of the information when we initialize the object. So inside init, we can actually create the class attributes. So we could say, hey, this particular instance, and let's say the make is equal to make. And that means we're going to have to pass in make every time we create a new car. But that's fine. We should know that information when we create it. And we can kind of go ahead and do that for all of them. Self.model equals model. Self.year equals year. Self.tires equals tires. And self.color equals color. I'm going to get rid of tires. I think 4 will be good enough for this example here. I'll keep the hello, but we will have to pass in all this information every time we create an object. So let's go ahead and kind of put in some information and make sure it runs. Alright, we'll run this again. So everything works as intended. We're going to create a new object. We're going to pass it all the information, the make, the model, the year, the color, and we're going to get that in when we instantiate it. So because these are attributes to the class, we can kind of call them. We could say, hey, I want to print car1.make. So let's try that real quick. And we get Porsche. So we can kind of just access any of the attributes of that specific object as if they were a function. So let me get the make, let me get the model, let me get the year, and let me get the color. So you can kind of see when you have a larger program how much cleaner this would be, especially when you have many car objects. You can kind of just say, let me get the one object I'm looking for, let me get that attribute, or let me call a function of that class. So for example, let's say we wanted to change the color of the Porsche. We could say, we could define a new function right inside the class, change color. We always want to pass itself because we're talking about this particular instance that we're in, and we're going to give it a new color. I'm going to say new color here actually. And we just say self.color equals new color. That's it. So if we say car1 dot new or dot change color, and we make it yellow now, and then we print the color again, let's see what happens here. So it was lime green, but then we had a function within the class that allows us to change the color, and we printed it again. So one of the big things that object-oriented programming allows us to do is create reusability. We can reuse our code. When we were doing procedural programming with just functions, yeah, we could have multiple uses for a single function, but in object-oriented, you can really use a single class and reuse it, or a single instance and change it up. And you see that example with the colors. You can easily change the color of the car. So piggybacking further off Jan's example from last week, let's say we had a state here, self.state equals off. So the car is off to begin with. So let me delete some of this information here. And we can create a function called turn on car, which it doesn't need any parameters. It just needs self. We don't need to tell it, hey, this is what you got to turn it on to. And we could say self.state equals engine running. So again, we can print car1.state, and then we can car1.turn on car, and then we can print the car1 state again. So whenever we create a car, it's always off. We're not even giving it an option to say, hey, we want to put the parameter of on or off. We must call the function turn on car and change the state at which it's in. So you can see how you can also hold states within your objects. This is just another example of how you might be able to use object-oriented programming within your code. Now, sometimes when you learn a new trick in programming, you kind of want to use it everywhere. But that really shouldn't be the case with object-oriented here. It really has practical use when you have a particular object which has functions which relate to it that you can kind of organize within a good manner. I know that's a lot of words. For example, if we had a student grade book, we'd be able to organize all the different students. If we had a book list, let's say we were creating a bookstore in Python, we could have all the different books, the prices, the author, and all that information as an object. So we could have a class called book, and then we could have all the books inside the bookstore. It just helps to organize your information if all of the functions kind of relate to itself. I hope that makes sense. So I don't want to go too in detail about all the different things you can do with object-oriented programming. I kind of just want you to see a few different examples so it becomes a little bit more familiar. This type of programming paradigm isn't something you're going to get with one piece of code. You really got to play with it a few times, and then it will start to click and make sense. One thing I found when I was learning this is it's always useful to draw it out. And especially before you start programming, let's say you're creating a object-oriented program and you know you want to use object-oriented, we're making a book list. Always kind of draw it out on paper or draw it out in the text editor before you commit to it. When you do an object-oriented design, you don't want to mess up the foundation. So you really want to think through how you want to set up your classes before you go ahead and set that up. So let's do that now. I created a new file here, oop2.py, and we're going to just create a book list for a bookstore. So what kind of information, what kind of attributes does a book have? It has an author, it has a title, and it has a price. That should be good for now. If we wanted to add stuff in later, we could create functions within the class and kind of add more information. But let's go ahead and flesh this out a little bit. We're going to have a class called book, and we're going to want to define that constructor, aka initialize or init. We're going to pass it self, title, author, and price. And then let's go ahead and just kind of kind of put it in. So self.title is equal to title. Self.author is equal to author. And self.price is equal to price. And then one thing you can do here is actually declare the types right in the init function. This is just a cleaner way of declaring, hey, this is the type I want, and if I get something different, I want you to convert it. So we know the title should be a string, the author will be a string, and we'll go ahead and just say price is an int here. All right, cool. So what we're going to do is actually create a book list. It's going to be a list of all the different books that we like to read. And so one of the ways we can do that is by creating a book list and then just appending objects to that list. So we could say it's append a book with the title Harry Potter. We know that to be written by Wizard G. And it has a price of $20. And let's go ahead and compile this and just make sure it runs. All right. It looks like everything's cool with the compiler. So let's append some more books here. Just gonna do 4. So I'm gonna be a bit lame here. I'm just gonna Google top books of 2020. But it'll do the trick here. The Glass Hotel, that's written by Emily. Uncanny Valley, that is written by Anna. Let's just give them random prices though. And Deacon King Kong, that's an interesting title. That is written by James. So we'll compile this again. All right, it's happy. So what we can do with this is kind of iterate through our list of books and just print it out based on maybe name. So for book, I don't need the parentheses, for book in a book list, print a book dot title. So boom, we get all the book titles in a very organized fashion. And look how clean this code is. 16 lines. So yeah, we could use a tuple to hold this information, but now it's customizable. We can kind of add stuff to the book without any problems. So for example, we want to add page number, define page number, set page number, and we're going to pass it self and page number. We could say self.page number is equal to page number. So now we can also set the pages within the list. So this wasn't something we had when we started out, but you know, this is something we realized we wanted to add in later. So we can kind of just say book.setPageNumber, and let's just say 50 here. And then we can kind of just pick a book in the list and print the title and print the pages just to see it in action here. Print book list sub 0. We're gonna get the title first, and then book list sub 0. We are going to print out the page number. Alright, cool. So the first book on our list is Harry Potter with a page number of 50. All of them are 50, but it was just to show you a quick example here. So I hope this was a good introduction to object-oriented programming if you have never seen it before. Again, if we run through, our goal is to create an object which you can then instantiate somewhere in your code, and you can have set functions within that object that perform specific actions. So in this case, we had a book object which held a title, author, and price, and we were able to set the page number later on if that was a needed attribute of the object. In our first example, we had a car, and we knew the make, model, year, and color, and we had a state which we were able to control after the fact, and we could take it for a paint job and change the color if needed after the fact. And we learned about the init function, which is a constructor. It initializes the class whenever you first instantiate it. This is instantiating the object. We are declaring a new object, and we're going to pass it the parameters at which it needs. And then we can just kind of access the attributes of that object as we're going in our program, and we can access the functions of that object and kind of organize our code in a object type manner. So one of the things we've seen here is something called encapsulation. What encapsulation means is that we're kind of hiding away some of the information that might not be needed. So for example, in book, you could kind of have the class in a whole separate function, and you would just call book and pass it the parameters you need, or set pages. You kind of simplify the amount of information. You hide it away, you encapsulate it. This is a core principle of object-oriented programming, encapsulation. So I think it's important to restate that this subject might seem foreign, kind of abstract at the moment, but as we continue these lessons, the implementation and ideas of object-oriented programming will make more sense. And as you play around with the code yourself, these ideas will also begin to make more sense.